All right, let's just jump right in. For decades, we've had this one really powerful idea for what the human brain is. But what if that whole idea is just completely wrong? Today, we're going to explore a wild new theory that basically throws out the old rulebook. It suggests our consciousness isn't built on logic at all, but on rhythm.
You've heard this question a million times, right? It's defined how we think about neuroscience, AI, everything for the last 50 years. We imagine our brain as this super-fast biological computer processing information. But that model has some serious limits. It doesn't really explain creativity or where self-awareness comes from, or how the brain just runs itself, you know? So what's the alternative?
Okay, so on the left, you've got the idea we all know. The computer brain. It's built on hardware, it crunches ones and zeros, and it computes answers. But on the right, whoa, we're looking at something completely different. This new theory proposes a time crystal brain. Instead of logic, it creates rhythm. Forget ones and zeros, it uses geometry and actual shapes. And here's the most mind-bending part. It's not really built on physical hardware, but on the patterns of time itself. This is a huge shift in thinking. To even begin to wrap our heads around this, we have to start with this single most fundamental piece of the puzzle. Think of it as like the first violin in this incredible orchestra. It's a concept called the time crystal.
Imagine a perfectly crafted bell. It has this pure, natural tone, its own unique rhythm. Now, if you strike it, the sound changes for a second, right? But it always, on its own, returns to that original, perfect tone. A time crystal is exactly like that. It's a self-healing clock. It's a system with a natural rhythm that, no matter what you do to it, always finds its way back home.
So here's how that actually works, in 4 simple steps. First, you've got a stable clock, just ticking along. Then, boom, an external force hits it. A sound, a sight, anything. For a split second, that disruption creates a brand new temporary clock. But then, and this is the magic part, the system just corrects itself and goes right back to its original rhythm. This ability to get knocked off course and always find its way back is what makes this whole idea so powerful. Okay, so we've got these individual clocks, all healing themselves. But a brain is a network, right? They have to connect. Well, the secret ingredient, according to this theory, is something called a singularity. Now, we're not talking about a black hole here. Think about a pendulum swinging. At the very top of its arc, for a tiny fraction of a second, it's perfectly still before it changes direction. In that moment of pause, its state is, well, it's undefined. These little pauses are the junctions where different clocks can link up and talk to each other, creating this massive, complex web. And this is where the theory goes from just fascinating to absolutely mind-blowing. Because it turns out this whole structure isn't random at all. It looks like nature built our biology using a kind of secret mathematical code. A blueprint that's been hidden in plain sight this whole time.
7, a prime number. Seems kind of random, doesn't it? But what if I told you that numbers, just like this one, numbers that are indivisible and totally fundamental, are the actual blueprints for the brain?
And check this out. This just illustrates the point perfectly. Look at our biology. The human eye? It's built from 7 main cavities. The key molecule in your eye that senses light? It uses a chain of 11 carbons. The tiny microtubules inside every single one of your neurons are made of 13 filaments. And the cortex, the part that does all the heavy thinking, has 7 distinct layers. It's like prime numbers are nature's favorite Lego bricks. So, we have clocks, they're connected by these weird pauses, and they're built using a prime number blueprint. But how does the system actually, think? How does it represent information? The answer isn't in bits and bytes. It's in something way more elegant: geometry. I know, that quote's a bit of a mouthful, but here's what it boils down to. Information is represented as a shape. A simple shape, maybe a triangle, could be a single piece of data. And then that triangle itself can become just one corner of a much, much bigger and more complex shape.
Just let that sink in for a second. This isn't a metaphor. The theory is proposing that a memory isn't just a string of data. It's a specific geometric form. A feeling isn't just a chemical reaction, it's a shape, vibrating in this architecture of time.
And this information gets more and more complex as it moves deeper into the brain. So think of it this way. Simple sensory input, like light hitting your eye, starts out as a basic geometric shape. As that signal travels to the midbrain, it fuses with other signals, and it becomes a more intricate, higher-dimensional shape. By the time it gets to the cortex, where we do our most complex thinking, it has evolved into this incredibly rich, multifaceted geometric structure. It's literally a journey from simple shapes to profound, complex thoughts. Okay, so now let's zoom out. We've looked at the single instrument, that time crystal. We've seen how it codes information into shapes.
So how do we put the whole orchestra together?
This is honestly my favorite analogy from the whole paper. All the infinite ways these clocks can interact, getting disturbed and then returning to their rhythm, they don't create chaos. They create this beautiful, ordered map of every possible outcome. They call it a meander flower garden.
So the theory actually identifies 12 major systems in the brain that act like these complex gardens. And we're not just talking about the big stuff like the cortex. It includes everything from the nerve network in your skin all the way down to the tiny microtubules inside every cell. Each one is its own orchestra, its own garden of possibilities.
So what we get is this really beautiful nested structure. You have 12 unique gardens of clocks, and altogether they form a garden of gardens, a complete, self-organizing symphony that is the brain.
Now, if this model is even partly right, the implications are, well, they're staggering. This isn't just a new way to think about the brain, it could be a new way to think about reality itself.
I mean, this could redefine our understanding of just about everything. It could give us a totally new way to build truly conscious AI, not by programming logic, but by orchestrating rhythms. It gives us a physical way to think about memory, storing it as geometric shapes, and maybe most profoundly, it gives us a new angle on the biggest mystery of all, self-awareness.
And here it is, a potential scientific definition for one of life's greatest mysteries. In this model, self-awareness isn't some kind of magic. It is the specific, maybe even measurable, ability of the brain to create and run 3 separate, complete geometric information structures at the exact same time. Consciousness is a symphony played in triplicate.
So we'll leave you with this final thought. For centuries, we've been trying to find the ghost in the machine. But maybe there is no ghost, and maybe it's not a machine. Maybe it's just this infinitely complex, self-tuning orchestra of clocks. And if every thought, every feeling, every memory you've ever had is just a geometric shape, what beautiful and complex shape is the reality you're experiencing right now?